me a definition of a central angle. It says these are central angles, right? These are not. Isn't that what it says? These are central angles. These are not central angles. Yeah, QSR are not central angles. Who could give me a definition of a central angle? Central angle. Yes, Anna.
Angle from the radius?
Yeah, from the center. Okay. A central angle. So a central angle is it's an angle in a circle with its vertex at the center. That's all it is. Okay. Now let's look at the next part. Is recording? Am I recording now? I'm recording. Okay, so with a central angle vertex at the center, inscribed angle, the vertex is on the center. So that was an investigation. That's called investigation. This one, so if you did measure these, okay, and you measured this angle here and this angle here, you should have got that those two things are congruent, right? And we drew these. What the heck? What did that do? We drew this such that this piece was congruent to this piece, right? So in this conjecture C55, it should say, if two chords are congruent, then they determine two central angles that are congruent as well, okay? Congruent. Now, I don't know if you guys remember, but when we did define circles in the very first, I think it was way back in chapter 2, okay? If this angle here is, say, 75 degrees, this arc here, this arc from here to here is also 75 degrees. We covered that, right? First semester, okay? The central angle is the same as the measure of this arc, okay? So if this is AB, this is arc AB, and we'll call this measure of AXB. Whoops, measure of angle, I messed up. Measure of angle AXB is equal to 75, then it follows that the measure of arc AB is also equal to 75 degrees. So the measure of the central angle is equal to the measure of the central arc. Using that, we can go on to the next conjecture, right, which is C56, because, let me see if I can find that. Where is that conjecture sheet that I just showed you guys? Is it there? Not there, not there. Let's see, conjecture sheet. So if we go to C56, which is the next one, okay? It kind of follows, if I were to draw in two chords that are congruent, so say here's a chord, right? And I draw in the central angles as well, here and here and here. Oops, I meant to do different colors, that's okay. Okay, but if I know that this is congruent to this, what has to be true about these two arcs? If this chord is congruent to this chord, what has to be true about this angle and this angle? These angles are congruent, right? And if these angles are congruent, what has to be true about arc AB and arc CD from here to here and here to here? They're congruent as well. So that's kind of what this next conjecture says. It's just kind of using deductive reasoning. If two chords in a circle are congruent, then they're intercepted. Whoops, it's not very good writing. Then they're intercepted arcs. Intercepted arcs are congruent. Okay? So what an intercepted arc is? It's which piece of the arc is cut off. Okay? So by the radius or by sides of an angle. So this is an arc AB. If, in this case, if AB is congruent to segment or arc CD, okay, then, why does it keep doing that weird line all over the place? Then arc AB, the measure of arc AB is equal to the measure of arc CD. Okay, so if this chord is congruent to that chord, then these arcs are congruent. Good? Okay, so that's C56. Now it's your turn. Okay, so 59. Tell me what you discovered about C59. You must have done this one by now. Perpendicular bisector of a chord passes through the what? Center of the circle. Okay? So if you go to, I keep losing that thing, but C59 you should write, right? As you notice, whenever I made the perpendicular bisector of these chords, it always goes through the center of the circle, right? And so that's kind of a cool thing. I think it's kind of a cool thing. Wait, where'd it go? So C59 should say that C59, how does it start? On the back page, perpendicular bisector of a chord passes through the center of the circle. Goes through the center. Through center. And what's really cool about that, you'll have a homework problem where they say, okay, here's they find this dish. Say this is part of a circle. And they want to reconstruct, it's a plate from ancient times or something like that, and they want to reconstruct the plate. How can I find the center of a piece of a circle? How can I find the center of a piece of a circle? It's going to be in a quiz. Go ahead, Ben.
So you make a picture of any chord.
Yeah, you make any chord, right?
And then make a perpendicular bisector.
Yeah, so if I take one chord, right, and I do the perpendicular bisector of that chord, is that enough to find the center? You need another one, right? You need to see where they cross. So then if I did another chord anywhere on this arc of the circle, anywhere, right, and I found the perpendicular bisector of this chord, right, then this point right here would have to be the center of that circle, right? Because both of those chords after that. So if I put my compass here, I mean this is very, very, very rough, but if I put my compass here, look at that. It would find the center of that circle. Isn't that cool? Kind of cool. All right, I think it's kind of cool. So in this case, what you're going to do is you're going to make a perpendicular line, okay, from this point to this segment, like that, okay? And then I say put a point on the circle there, okay? And then you're going to measure the distance from here to here and the distance from here to here. To measure, you use this thing. Use this thing. Wait, use this thing. Distance or length, right? And so you could just measure from here to here, and then from here to here. So that one should be pretty easy. I'll let you finish that one up. Oh, wait, are you guys getting this? This is fun here. Okay, so now put a point right there. And now measure from here to here, from here to here. So go up here. Distance from there to there. Okay. There. What do you notice? There. So that conjectures 58, I think. 57. The perpendicular from the center is the length of the chord. So what if it's perpendicular, what do you call that if it cuts in half? Huh? Perpendicular back, cuts in half. What do you say is the what? Perpendicular bisector? Did you get that? C57? C57. You should have got that those lengths are the same. Whoops, I'm still recording. Okay. So C57, you should have discovered that if you measure these two pieces, they come out to be the same, right? And if I make a perpendicular from here to here, then C57 says a perpendicular to a chord from the center of a circle to the chord is the perpendicular bisector. Perpendicular bisector of the chord. That's C57. And I'm going to let you try that last one on your own. Okay? So if I drag this segment from here to here, and I make this like 6 or something like that, 6, and I make the other one 6 as well, are they still the same distance from the center? Yes, okay? So that's conjecture C58. Two chords in a circle are where's my tool? Okay. Two congruent chords in a circle. So if these chords, this chord is congruent to this chord, that means that this piece, this distance, since that's the distance because I always measure distance at a right angle to the center. Okay. So what do you call if two distances are the same? What's the big word for that? Equidistant. Okay. So C58 should say that two congruent chords in a circle are equidistant from the center of the circle. Okay. And I think now that let's just do a couple more example problems that I want to show you things you might see in your homework. So one type of homework problem you might see is where you have something that you have a circle and then you have a chord here and you have a chord here, and they tell you, even though it doesn't look like it, that this is 150 degrees from here to here. And they tell you that this is 100 degrees from here to here. And they tell you this is congruent to this. And they say find x, which is from here to here. What's x? 10. Yes. Is it?
Yeah.
Is it 10? How come? That's right. How come it's 10? Drawing not to scale. Drawing not to scale. If this is 100 and these two chords are congruent, how far does it have to be from here to here? How far does that have to be? 100, right? How many degrees altogether in a circle? 360. So what's left over for x? 10, right? So even though it doesn't look like it, x is going to be 10 degrees. All right? Okay? And then I just want to do one more example, and then, yeah, we got time. Okay? So one more example. Say I have a circle that looks like this, and I have a triangle at the center of the circle. And then I tell you, I call this little angle here y. And I tell you that this arc from here to here is 200 degrees. Find y. Who can tell me how I can find y? Who tell me how I can find y? You're going to have some homework like this. How am I going to find y? If this is 200, what does this have to be over here? 160, right? 160, right? Which makes this central angle how much? Same thing, right? How many degrees in a triangle? 180. These are radii, right? So what's got to be true about this angle and this angle? Has that up to 180, so what's y got to be? 10, right? The answer is always 10. No, it's not. Okay. But, so